Hello everyone, my name is Dan Yu. I'm responsible for driving AI ML innovations into design verification products in Siemens EDA. So today I would like to share the most exciting development new horizon of AI in static and formal verification. So if you have any questions, my coworkers in the meeting would love to answer. If you have any specific question targeting me, they will direct the question to me and I will catch up with you offline. Thank you. And then I will go to the first page. As many of you are aware of, the existing verification tools are mainly based on deterministic algorithms. So basically, we research what kind of algorithm might work for verification and we program them into our product. So with AI, they can learn from data and they can automatically program more complex logic into the verification product. So we have seen a new level of productivity achievable with AI to complement the traditional method to maximize acceleration efficiency with increased confidence to achieve your productivity goal. How do we unlock the potential of AI to revolutionize verification? There are three different areas we can address with AI ML. The first is we make engines faster to replace the existing heuristics and the graph analytics in core engines and tools. The second is having more impact to enable verification engineers to move faster. So to enable new creation, analysis, and debug capabilities. The third one has even more impact. So AI ML can take some load off our engineers with predictive technologies to streamline and accelerate your verification. So if you look at your workflow, you will see that a typical verification workflow includes creation, execution, analysis, then debug. And in every step, you have a lot of data generated. In the past, we didn't realize the value of the data, but when you aggregate the data together with big data, and on top of that, you use AI ML to analyze the data to provide you additional insight. Actually, with the help of AI, you can achieve your time to market faster. When we look at the four steps in your typical verification workflow, we see that with AI, we can make your creation smarter. And with AI, we can make your execution smarter with smart regression. And we can make your analysis smarter with smart coverage closure. And the last, with AI ML, we can make your debugging faster with smart debug. So in the next few slides, I will cover the typical applications we are actively developing in-house about those four pillars of smart verification. Smart creation is the first step of a typical design verification workflow. The first application of AI ML in smart creation is to leverage the power of large language model for RTL and UVM test bench generation. So, it's really time consuming to write high quality RTL code for a new design, or especially if you have some unfamiliar language methodology you need to master. And our solution is to leverage the power of a fine-tuned large language model to generate both system Verilog designs and UVM code. The learning data comes from open source HDL projects, but also we have some in-house HDL code and we have some specification documents. So the DVT assist we are showing here is actually already a productivity tool we have in-house. Here we are asking DVT Assist to generate a 7-segment BCD decoder. And as you can see, it's doing pretty well in the generated BCD decoder. So the beauty of this solution is actually everything stays in-house. So every piece of data is staying in your organization. And we have demonstrated that with the server of, let's say, 10,000 K US dollars, you can actually support a team of 20, 30 people if we assume everybody just asks a question every 1 or 2 minutes. And everything we showed here are in real time. So that means you really don't have to wait for large language model to generate some code. You can immediately make it very usable. I have to fast forward a little bit, but basically now we added FIFO buffer, and we encourage large language model to give us a simple UVM test bench based on this design. Okay, so coming to the next one. We also see that large language model can help you with smart creation with Copilot. So, when you are using a new product, you might spend a lot of time just to ramp up because it's a new tool. And the lost productivity in finding the right answer when you are using the product could be saved by such a kind of Copilot. It's a large language model document answering system, but actually behind it, we have all the product knowledge available. And as a user, you basically just need to ask questions in natural language, and we will extract the explanation from our document, but also will give you sample code, show you how to do it step by step. That's all made possible by this Copilot. It will learn from product documents, from our internal in-house data like Verification Academy and forum, and we also have our knowledge base. When we were servicing our customers, we have accumulated a lot of knowledge, and we also have knowledge about how to operate our product from QA. So all the knowledge are consolidated to provide such kind of Copilot for our users. And here is example about QuestLint. So we ask how to run QuestLint on each module separately, and it will not only give you the answer, but it will also show you the code, how to run it. This is very helpful, and of course, it will also show you the link to those examples to the right page of the documentation. The other application of machine learning for smart creation is assertion generation. As anybody with experience about formal verification should be aware of, most of the labor time is actually spent on creating SVA assertions is time consuming and it's hard to get it right at the first time. So what we are doing is we are making fine-tuned large language model to enable automatic generation of SVA assertion code, for example, from your standard document or from your natural language description. The large language model is fine-tuned based on HDL code, specification document, grammar files, and some more SVA examples. So with that, large language model would be able to look at the context information, so basically the design itself, and also look at your natural language description of the specification, and it will generate SVA for you, and you can then inspect the SVA, and maybe it's not exactly 100% faithful understanding of the specification. You may need to adjust it a little bit, but we see it's a very powerful assistive tool to help you improve the productivity of assertion creation. Now we come to the second pillar of smart verification, smart regression. You know, the concept of regression is normally in simulation-based verification, but actually we also see that in formal verification, a lot of time are spent just to run the formal engine to solve your properties. This is where machine learning could help. So we look at different solvers, and actually we have seen statistics that different solvers have different capability in solving a specific property for a specific RTL design. So what we are doing with machine learning is we look at all the features in RTL design, and we look at the features of SVA properties. Then we use neural network to give the prediction. Okay, according to my observation in the historical data, I believe solver 1 is more powerful for this design and this property. We should allocate more CPU power to solver 1 in order to solve this property faster. So the machine learning prediction does not directly solve your property, but instead it helps to allocate the resources, computing power, to the most promising solvers. And what we learn is from historical solver performance, and we learn from design and design and property features, and we also learn how much computing resources are used in the past formal verification. We all know that with formal verification, it's really hard to debug formal properties. However, with smart debug powered by AI, we can accelerate your debug turnaround. So this is just one example of using AI ML for smart debug. So here, we can leverage the power of large language model again to assist formal property debug. You know, you or your coworker may have to inherit some legacy code, or you have written some code for a long time and you totally forgot it, or you have some very hard to understand SVA written by your creative coworkers. So coming to that, if properties are hard to understand, large language models can be very, very helpful to explain, to help you understand the subtle semantics in SVAs. And our large language models are fine-tuned on HDL code examples, specification documents, grammar files, and existing SVA files in-house. So the example we showed on the right-hand side is basically we have some assertion about a counter. So actually that assertion should include both upper bound and the lower bound. And obviously it's missing the lower bound. So with English language description, you can easily see, okay, what that assertion is about and what I'm missing. So with that, you basically use AI to push you, double check the result, and if there is any mistake, you can take that understanding moving forward to revise your code. This is how a typical debug workflow could look like for your formal verification. The last piece of smart verification is smart closure. Here, we are looking at, so AI ML can also help you with clock domain crossing and reset domain crossing. So we have CDC, RDC assist. They can help you automate the clock reset domain analysis and to accelerate your crossing closure. Normally we need to spend hours just to analyze thousands of related log messages, the signal connectivity, just to pinpoint the common issues in the configuration tool. So instead of doing that manually, our CDC RDC assist can automate the message clustering to reduce noise, to generate constraints, and to provide you corrective action suggestions. So after CDC RDC assist checking, you can really pinpoint where you might have CDC RDC violations and how to fix them. On the right-hand side, we have some examples to show you that with CDC RDC assist, how much you can reduce, how many violations you can reduce with those tools. So the examples I showcased just now are just a small subset of all the AI ML features coming in static and formal products we are actively developing or already available. So we see great opportunities to improve productivity with those tools with better results, faster. As I explained, CDC, RDC, and Glitch Assist, they are already available. You can order now. And we also have some beta products. We are looking for early adopters. You can play with those products like AI Cloud Ready Architecture. It's called IVE, Integrated Verification Environment. And we have Lambda Copilot. You have seen the demo, and if you're so interested, we may give you a deep dive of the technology and see if the product you're interested in is covered by the Copilot. And a big cluster of new AI ML products we are developing. We need partners to prioritize our resources. We need to know from your experience, from your perspective, which product should appear earlier so that you can be the first batch of the pilot users to play with it, to share your feedback, and to see productivity improvement in your daily work. So like formal engine orchestration, I already explained, SVA property generation, assisted formal property debug, large language model based code test bench generation, and also there are many technologies I didn't get the time to explain, like Assist Plus, chirality collecting, equivalence assist, lint and inspect assist, machine learning enabled auto fixing, and result-based flow suggestion. So you see, there are many interesting technologies, and if you are interested in those I have not mentioned, you may ask my coworkers in the meeting. They will give you better explanation. Ultimately, we are looking at smart verification as a way to accelerate efficient functional verification with the power of AI. From smart creation, smart regression, smart closure to smart debug. And we see with them, we can help you with faster engines to make your engineers more productive and to reduce the workload. All of them are here powered by AI. So we have shared a lot of examples how AI ML can help with formal and static verification. So I hope those examples can give you some inspiration, um, help you think about how AI ML can help in your daily work. So that's the end of my presentation. Thank you again for your attention. If you have any questions, you can ask in the meeting. My coworkers will be able to assist you, share their thoughts on those questions, comments, and you may also reach out to me at dan.yu@siemens.com. So my name is simple, only 5 letters. Apologize again for not being able to join you in person, but really appreciate this great opportunity to share AI ML development in the horizon. And I hope with your help, with your thought, we can prioritize our development, make the product available to you to help your productivity boost as early as possible. Thank you again. Bye.